There is a 1994 Ram 2500 rolling around Texas right now. It has 743,000 miles on the original engine, the 5.9 Cummins 12-valve, still running the P-pump, still running the original turbo. The owner changes the oil every 5,000 miles. That is it. That is all he has done for 743,000 miles. That is not a rare case. I have seen a 1991 Ford F-350 with the 7.3 IDI hit 810,000 miles. The injection pump never been touched. I have seen a 1993 Chevy Silverado with the 6.5 Detroit diesel stack 690,000 miles on the original motor. These trucks exist. They are not unicorns. They are not preserved in climate-controlled garages. They are working trucks, hauling loads, getting used every single day. The reason is simple: mechanical injection. That is the whole loophole. Before 1994, before the EPA started strangling these engines with electronics, these motors were built like iron. They were simple. They were fixable. They were built to last 500,000 miles because that is what truck owners needed. There was no other choice. I'm Wade Tucker. I have been turning wrenches on pickup trucks since 1986. I started in my uncle's shop in Odessa, Texas. I have watched the diesel engine evolve from a mechanical miracle into a computer with a motor attached. I have owned every major diesel truck made since the 1980s. I have taken apart engines in my shop and I have rebuilt them. I know what breaks and what does not. I am going to tell you exactly why the old mechanical diesel engines will outlive anything modern. And I am going to tell you which ones to look for, what they cost, and who should buy one. If you are new here, subscribe, hit the bell, leave me a comment and tell me what year your truck is and how many miles are on it. I read every single one. Let me start with the three motors that define this era, the holy trinity of mechanical diesel, the engines that made these trucks worth buying. The first is the 12-valve Cummins 5.9. This is the 6BT engine. Inline 6, 5.9 liters, 12 valves, mechanical injection pump. It came in the Dodge Ram 2500 and 3500 from 1989 to 1998. It made 160 horsepower from the factory. That sounds low by modern standards. It is misleading. The 12-valve made 400 pound-feet of torque. That is more than most modern V8 diesels make, and it made that torque at 1600 RPM, low in the rev range, right where you need it for pulling a loaded trailer. The 12-valve does not rev high. It does not need to. It pulls from idle to 2500 RPM. That is its whole range. It was designed for work. The second engine is the 7.3-liter Power Stroke IDI. This is the indirect injection version, not the later 7.3 Power Stroke with the electronic controls and the HEUI system. The IDI came in Ford trucks from 1988 to 1994. It was also an inline 6, 7.3 liters. It made 185 horsepower and 388 pound-feet of torque. The IDI stood for indirect injection. It used a pre-chamber in the cylinder head to atomize the fuel before it entered the main combustion chamber. This was an older technology, but it was proven. It was reliable. It was nearly as tough as the Cummins, and parts are everywhere because Ford put this engine in delivery vans, school buses, and motorhomes across the country. The IDI is the one you want if you're on a budget. It is the underappreciated gem of this group. The third motor is the 6.5-liter Detroit diesel. This came in GM trucks from 1992 to 2000. It was a V8, 6.5 liters, 8 cylinders, mechanical injection. The 6.5 is the odd one in this group. It is not as bulletproof as the Cummins or the IDI. It had some oiling issues in certain applications, especially in the heavier GM trucks. The oil pump could fail at high mileage if the oil was not changed regularly. There were also issues with the harmonic balancer and the front cover seal. But when it is healthy, it is a solid motor, and the mechanical injection version is far more reliable than the later electronic 6.5 that came with the LB4 and LLY controls and the electronic unit injectors. The mechanical 6.5 is manageable. The electronic 6.5 is a headache. Now let me explain why these three engines will outlast any modern diesel. This is the mechanical injection loophole, and I am going to break it down piece by piece. A modern diesel engine runs on a system called high pressure common rail, HPCR. The fuel is pressurized to 30,000 psi by an electric pump that sits in the fuel tank or on the frame rail. It pushes fuel through a steel rail that runs along the cylinder head. Then piezo injectors spray fuel into the cylinders. Each injector is a precision component. It uses a piezo crystal that expands when electricity hits it. That crystal pushes a valve. The valve sprays fuel in multiple pulses per injection event. The engine computer controls exactly when to fire, how much fuel to spray, how many pulses to use, and what the injection pressure should be. This happens thousands of times per minute across 8 cylinders in a V8 diesel. Each injector in a modern diesel is a precision component that costs $400 to $600 per unit from the dealer. That is not including labor to install them. Times 8 cylinders on a V8, you are looking at $3,200 to $4,800 in injectors alone. Then you need the high-pressure fuel pump. That is another $800 to $1,200 for the part. Then you need the fuel lines and the rail and the pressure sensors. You can spend $6,000 to $8,000 on the fuel injection system of a modern diesel before you have touched anything else. You can rebuild an entire 12-valve Cummins P pump for $800 to $1,200. You can rebuild the entire top end of a 12-valve for $2,000 in parts. You cannot say that about a modern diesel. Here's the other part of the problem: the engine computer, the ECM. Modern diesels have multiple computers: the engine computer, the transmission computer, the emissions computer. They talk to each other over a CAN bus. They monitor everything: oxygen sensors, exhaust gas temperature sensors, turbocharger boost sensors, diesel particulate filter pressure sensors, NOx sensors, crankshaft position sensors, camshaft position sensors. If one sensor fails, the computer detects it, logs a fault code, and may derate the engine. It cuts power. It puts the truck in limp mode. You might not even know which sensor failed. You need a diagnostic scanner that costs hundreds of dollars. You need a laptop with the manufacturer's software. You need the knowledge to interpret the codes. Then you need the right part and the right tools to fix it. Now look at the 12-valve Cummins. The injection system is a Bosch P pump, P for Pumpe, German engineering from the 1970s that works to this day. It is a mechanical injection pump. It is driven by the engine's timing gear at the front of the block. It has a camshaft inside that pushes fuel to each cylinder in sequence through high-pressure lines. The pump meters fuel mechanically using a governor and a control rack. There is no computer involved. There is no sensor to fail. There is no software update. There is no limp mode. If the P-pump is getting fuel, the engine runs. That is all there is to it. The P-pump is famous for one reason: it rarely fails. When it does fail, the fix is usually straightforward. The injection pump timing can slip. That happens if the pump drive gear loosens or the timing belt jumps. That is a 30-minute job with basic tools. You set the timing with the fuse cover method. It is a known procedure. Any diesel mechanic in the country can do it. The fuel rack can stick from old diesel fuel varnish. That is usually fixed by cleaning the rack and lubing it with ATF. The injection pump itself can wear out after many hundreds of thousands of miles, but it usually does not fail suddenly. It gets tired. It loses pressure. You can tell by the loss of power and the black smoke. Rebuilding a P-pump is a known procedure. A full rebuild costs $800 to $1,200. Compare that to $5,000 or more for a modern injection system repair at the dealer. This is the mechanical injection loophole. Less complexity, more durability. When something breaks, you can see it, you can touch it. You can fix it in a driveway with basic tools and a parts manual. The other thing that made these old diesels tough was the iron block. Both the Cummins 6BT and the Ford 7.3 IDI have cast iron blocks and cylinder heads. The cylinder walls are thick. The crankshaft is forged steel. The connecting rods are beefy. These engines were built to handle high cylinder pressures and long service lives. They were built before emission standards forced manufacturers to reduce weight and increase efficiency at the cost of durability. They were built to survive. Modern diesel engines use aluminum cylinder heads and composite intake manifolds. They are lighter. They are more thermally efficient. They produce more power per liter. But aluminum head gaskets fail more often than iron ones. Composite parts crack under heat cycling. The power density is so high now that a head gasket failure on a modern 6.7 Cummins can take out the entire engine block because the aluminum is thin and the cylinder walls are sleeved differently than the old iron designs. The older iron block engines tolerated overheating much better. You could drive a 12-valve Cummins with a failing water pump for a while. You cannot do that with a modern diesel. Let me give you the timeline of what killed the mechanical diesel. This is important to understand because it shapes what you are buying when you look at these trucks. In 1994, the EPA introduced new emissions standards. The Clean Air Act amendments required significant reductions in particulate matter and NOx emissions from diesel engines. The 1994 model year was the transition point. The 12-valve Cummins was still mechanical in 1994 and through 1998. The 1998 model year was the last of the mechanical 12-valve Cummins. After that, the 24-valve Cummins came with electronic controls and the VP44 injection pump, which is electronic. The 7.3 Power Stroke went electronic in 1994 with the introduction of the T444E, which was the first electronic version of the 7.3. The mechanical 7.3 IDI ended in 1994. The GM 6.5 Detroit diesel was also transitioning during this period. Then in 2007, the EPA mandated diesel particulate filters for all diesel trucks sold in the United States. This was the biggest change since the 1994 transition. The DPF required even more electronics. It required exhaust gas recirculation systems that would route some exhaust gas back into the intake to lower combustion temperatures and reduce NOx. It required selective catalytic reduction. You now need diesel exhaust fluid, DEF. You need a separate tank for it. You need sensors to monitor the DEF level and quality. You need a computer to manage the whole system and to derate the engine if the DEF runs out. All of that electronics added cost, added complexity, added failure points, and it changed the fundamental character of these engines. A 2007 or newer diesel truck has a computer that controls everything. It has sensors everywhere. It has emissions equipment that needs maintenance and eventual replacement. It has particulate filters that need to regenerate. If you do not drive the truck hard enough or hot enough, the filter clogs with soot. If you use the wrong fuel or the wrong oil, the injectors foul. It is a system that requires attention in ways the old mechanical engines never did. The old engines did not care what fuel you bought as long as it was diesel. They did not care what oil you used as long as it was the right weight. The new engines are picky. The old engines were tough. Now let me talk about why these old trucks are actually increasing in value right now. This is not nostalgia. This is market economics. This is basic supply and demand. A 1994 Ram 2500 with the 12-valve Cummins P-pump in good condition sells for $15,000 to $25,000 depending on the market and the condition. 5 years ago, those same trucks were $8,000 to $12,000. The values have roughly doubled in many markets. Why? Because people figured out what I am telling you right now. These trucks will outlast any modern diesel. They are simpler. They are more durable. They are easier to repair. And there are millions of truck owners who have realized they need a truck that will just work without the computer drama and the expensive sensor failures. The 1994 through 1998 Ram 2500 and 3500 with the 12-valve is leading this appreciation. These are the last trucks with the mechanical injection Cummins 6BT that also have the NV 4500 manual transmission or the 47RE automatic. The NV 4500 is a legendary transmission. It was built by New Process Gear and it can handle 1,000 pound-feet of torque. It is a heavy-duty manual that will outlast the truck. The 47RE automatic is a strengthened version of the 46RE that came before it. It is a 3-speed, but it is durable when maintained. These trucks have a following now. They have internet forums and YouTube channels dedicated to them. They have a community. The trucks themselves are getting harder to find in good condition. Rust is the main enemy. These were work trucks. Many of them spent their early lives in northern states where road salt ate through the frame rails and cab corners and bed floors. A clean 1998 Ram 2500 with the 12-valve Cummins and low miles is becoming a rare find. The good ones are being bought up by people who know what they are. Where do you find one? Facebook Marketplace is the best source right now. Search for 1994, 1995, 1996, 1997, 1998 Dodge Ram 2500 Cummins. Filter by your region. Be willing to travel. The prices vary by region. Texas, Arizona, Nevada, and California have the cleanest examples because of the lack of road salt and the dry climate. Expect to pay $15,000 to $28,000 for a solid crew cab long bed in good condition. A regular cab long bed is harder to find and sometimes cheaper because fewer people want them. A 1994 or 1995 model year might be slightly less than the 1997 or 1998 in the same condition. Craigslist is less reliable but occasionally has good deals. You need to be careful on Craigslist because there are more scams and more cars that have been sitting. Rust belt trucks are cheap because of frame rot. Do not buy a truck with rust through the frame rails. The frame is the structure of the truck. If the frame is gone, the truck is gone. You cannot fix a rotted frame economically. Walk underneath with a flashlight. Check the shock mounts, the spring hangers, the transmission cross member, the engine mount brackets. If you see rust bubbles or through holes, walk away. It is not worth the hassle. The 7.3 IDI Ford trucks are cheaper. A 1992 or 1993 Ford F-250 with the 7.3 IDI in decent condition sells for $8,000 to $16,000 depending on the market. These are undervalued right now. The 7.3 IDI is nearly as durable as the Cummins and parts are abundant. Ford used the same basic engine in delivery vans, school buses, and motorhomes across the country. The parts supply is massive because there are millions of these engines still running. The 7.3 IDI is a smart buy if you want the mechanical diesel experience without the Cummins premium. The trucks themselves are Ford trucks, which means they have different rust patterns and different weak points than the Dodges. The Ford front ends tend to rust at the fender wells and the door hinges. The frame is usually better on the Ford trucks than on the Dodges from the same era. The 6.5 Detroit diesel GM trucks are the cheapest of the three. A 1995 or 1996 Chevy Silverado 2500 with the 6.5 in good condition might sell for $6,000 to $14,000. The 6.5 is less desirable because it had cooling issues in some applications, and because the 8-cylinder configuration means there are more cylinder heads to maintain and more head gaskets to worry about. Make sure the previous owner addressed the known problems. Check the thermostat housing because they crack. Check for oil consumption. If the truck has been maintained and the cooling system is in good shape, the 6.5 is a solid motor. Let me tell you a story. A guy named Mike from Oklahoma. He bought a 1996 Ram 2500 crew cab long bed, 12-valve Cummins, 5.9 liter, P-pump, NV 4500 manual transmission. The truck had 340,000 miles when he got it. He paid $9,500 in 2018. He is a cattle rancher. He tows a gooseneck trailer. He hauls feed across his property every day. He drives 30,000 miles a year. He changes the oil every 5,000 miles with Rotella T4. He checks his coolant level and his air filters. That is his maintenance. He does his own brakes and his own ball joints because those wear out on these trucks. But the motor has never been touched. It uses no oil. It does not leak anything. It starts every morning in 10-degree weather. It has 780,000 miles on it now. He will not sell it. He told me he will drive it until the frame falls off, and I believe him. That is the pattern interrupt. That is what makes these trucks different from everything else on the road. There is no computer to reprogram. There is no emission system to fail. There is no turbo with variable geometry vanes that carbon up and require cleaning. There is a mechanical pump and a fixed geometry turbo and a cast iron block. It is simple. It is robust. It does not quit. When you turn the key, it starts. That is the contract these engines made with their owners. And they keep that contract for 500,000 miles, 700,000 miles, 800,000 miles. Now let me be honest with you about who should buy one of these trucks and who should not. I am not going to tell you these are perfect for everyone because they are not. You should buy a mechanical diesel if you want a truck that will last 500,000 miles with basic maintenance. If you do not care about Bluetooth stereo or backup cameras or touchscreen infotainment, if you want a tool that works, if you are willing to turn your own wrenches or pay a mechanic who knows old diesels, if you need a heavy-duty towing rig that will outlast any truck you can buy new, if you live in a state without strict emissions testing, if you understand that these trucks are older and they do not have modern safety features, you should not buy one of these trucks if you need a daily driver with modern amenities and warranty coverage. If you live in a state with strict emissions testing like California, New York, or New Jersey, which have regulations that make old diesel ownership complicated and sometimes impossible to register. If you cannot do your own maintenance and your nearest diesel mechanic is 100 miles away. If you need financing because these trucks are cash deals most of the time and banks do not like to finance 30-year-old trucks. If you are not comfortable with a manual transmission because the automatics in these trucks are durable, but they are old and they will need rebuilding eventually. Here is the real question I get asked all the time. Should you spend $25,000 on a 1998 Ram 2500 with the 12-valve Cummins P-pump, or should you spend $45,000 on a new 2024 Ram 2500 with the 6.7 Cummins and the modern electronics and the 10-speed automatic? Let me put it this way. The 1998 will still be running in 2040. The 2024 will be a computer on wheels that needs software updates and has sensors failing left and right and costs $800 to diagnose at the dealer. The 1998 is already 30 years old, and it is stronger than the day it left the factory. I am not exaggerating. I have dyno tested a 12-valve Cummins with 500,000 miles. It made more power than when it was new. The rings seated better after 500,000 miles of use than they did from the factory. That is not a knock on modern trucks. Modern trucks are incredible machines. The 6.7 Cummins makes 400 horsepower and 1,000 pound-feet of torque. It is a marvel of engineering. But it is a computer with a motor attached. And when the computer decides to have a problem, you are in for a very expensive lesson. The diagnostic fees alone at the dealer can be $200 to $400 before they even start fixing anything. I have had both. I have owned the old ones, and I have worked on the new ones. I know which ones I would keep if I could only have one truck. I would take the 12-valve Cummins every single time. Every time. If you made it this far, I have one question for you. What is the highest mileage truck you have ever owned or seen that still ran strong? Leave me a comment. I read every single one. Tell me the year, the make, the model, and the miles. I want to hear about it. I want to know what you have seen out there. If you want to see more videos like this one, subscribe, hit the bell. I post new truck content every week. We are going to keep talking about what works, what fails, and how to keep these machines running. Because that is what matters, not the marketing, not the specs on paper, not the magazine reviews. What actually works when you need to get a load to town at 5 in the morning in January. I'll see you in the next one.